Going to do, take a look up here, is we're going to go into y equals and enter those two equations. Y equals, clear out whatever's there. In the top equation, I'm going to put 0.2x, because instead of c, I'm going to put an x, plus 0.3. In the bottom equation, plus 0.4. Okay, you good? Now we're going to look at our graph and set our windows. So push the window button. We want to make our window match what's on this graph so it'll be easy for us to draw our lines. What do you see as the lowest number on the x-axis?
0.
Put that for x min, 0. What do you see as the biggest number?
18.
18, and it
20,
goes 2
20.
more. That's an invisible. Whoops, I got to go down.
20.
0, 0, go down. 20.
Why
Okay.
did you put...
I messed up, but I backed it up. Now, what does each box represent along the x-axis?
2. 1.
Well, it's going to 4, but each box is 1, huh? So let's make a scale 1 on the x-axis. Now we'll go down to the y. What's the lowest y?
0.
0 again. And then what's the highest y? Good. 4. Now here's the hard part.
0.2.
Oh, Brody's on it.
5.
Each box is going up by 0.2. They don't show us the numbers for each one, but the difference between this one and that one's 0.4 between them, and 0.4 between them, and that's 2 boxes. So do you see how each box is 0.2?
Yes.
That's what we're going to put in for scale, 0.2. Take your look at your window. Does it look like what you see on the screen?
Exactly.
Exactly. All right, let's graph.
Whoa.
There's one line.
Whoa.
There's the other line. Okay? Now, I'm getting you some rulers, and we'll figure out how to make this work.
I can pass them out, Mr. Brigade.
That'd be great.
Brody wants to pass them out.
Hey, Brody. I know the y-intercepts. Hello? Shh. Brody's going to do that quietly. The y-intercept is this piece over here, 0.3 and 0.4. I'm going to graph that first. Maybe I'll do one at a time. Okay? I'm going to do the milking by hand first. That starts at 0.3. 0.3 on my graph is going to be right here. I'll make that bigger. Shh. 0.3, this is 0.2, that's 0.4. So 0.3 is going to be right in between the first line that doesn't have a number and the 0.4. Okay? Now, I am going to see how to put this. I'm going to do a trace. Good. I'm on that top line. Look at this. I pushed trace because I need some more points to help me out. I put 0.3 first, and now it says when x is 10, y is 2.3. So let's see. Here's 10. And here I move up from 10, there's 2, that's 2.4. This line would be 2.2, so 2.3 would be right here, right underneath the 2.4. I found that on trace. I'm working with the top line. I know that's the by hand line because this is the amount of time. And so that one in the long run is going to be a bigger amount of time. So I have 2 dots, one at 0.3 and one at 10, 2.3. And then I'm going to label this so I remember this is by hand. Now I am going to use the down arrow, I think. Awesome. So I pushed the down arrow on my calculator and it dropped the cursor straight down. It still has x of 10, but now it has a different y value. That's going to be the other graph. I go back, though, to the equation. Remember, y-intercept is this piece. Guillermo, y-intercept is that piece right there. So I need to graph 0.4 for my machine graph. 0.4 for my machine graph as a y-intercept. It's going to be just above, on the graph, it's going to be just above the first dot I made. Now on my calculator, maybe I need to make it a tiny bit smaller. I did a trace, and I found out that when x is 10, y is 0.9 for this bottom line. When x is 10, y is 0.9. So let's find that on this graph. Here's 10, and here's 0.8. And this would be 0.10, 0.8, 0.10. So 0.9 is just above the 0.8 line. Okay, but that's not right, Brody. You just randomly put some lines down. Okay. Okay, so again, I'm doing the 0.4. I'm doing that second line that I found using the trace feature. And this is the by machine line. Now, let's look at this graph before we go on. Again, the independent variable is the number of cows. Dependent variable is time. Circle the word time there. It's good to remember what the graph and the situation represents. This is time that it takes per number of cows. This by hand goes up quickly. It starts lower at that 0.3, but it goes up quickly as you increase the number of cows. Over here, you could already see it. When we were at 10 cows, they were very far apart from each other. The machine starts a little bit more, but it's taking a lot less time per cow to go by machine. Questions so far?
Nope.
Got that? Okay. Maybe I'll put the ordered pairs that I... Nah, we'll flip the page. Let's move on. Use the graph to estimate the break-even point. Break-even point. What is break-even point in the graph?
No, even.
What things are even?
The number of cows and the time.
Well, one of those, or is it both?
Both.
Both. It's the intersection. Where do these guys intersect? I'm looking for can we see where they crisscross?
About 0.432.
They're really close on in. Is it actually over 1 cow? Okay.
It's on.
The crisscross is right there. Okay. The break-even point on your graph, right down below, break-even. It's right there. What do you think the x and the y is right there? They're asking us to use our eyeballs to estimate. Take a look down here on the x-axis. How many cows is that? Andy says 1. Wait. Okay. Andy says 1. Jerry says 0.73, so which is less than 1 cow. You guys put, how many cows do you think? That's the x-coordinate. All right, and now how high up is that crisscross? Is it above 0.4 or below 0.4? Look at your eyeballs. What do you think?
0.4.
You think it's just above 0.4?
Just above.
Just above. Should we call it 0.5 or
No.
0.45?
0.4, 0.32.
0.43.
2.
Okay, this is the time in hours. Okay, and it's the y coordinate. Yes. Okay, hold on, we'll get there. Okay, we're using our eyeballs. They asked us to estimate, and Jerry said, man, I got this graphing calculator. I bet it can tell me. Flip the page. So, in D, we said 1 and 0.43. What does a break-even point represent? What does that, wait a minute, Brody. What does that crisscross mean?
The break-even point.
Good. What does that mean in terms of the cow milking?
It's where it like represents which, like by hand.
Oh.
The coordinate.
What about by hand? How does that compare to by machine at the break-even point?
They separate into two lines. I got it right. For different coordinates.
But at that break-even point, yes, they're equal. Equals by machine. At that spot, it's the crisscross of the two lines. Right here, this is the hand line, and this is the machine line. Okay, and right at that spot, they're exactly the same X and Y. Exactly the same number of cows and exactly the same amount of time. That's break even. The two lines have that point in common. Write this down, please, Guillermo.
I did call it.
Awesome. Verify your answer by solving the system algebraically. Oh, that sounds like fun. All right, let's do it together. Solving the system algebraically, we set them both equal to each other. So 0.2 C plus 0.3 equals 0.05 C plus 0.4. Okay? What we did last week is we solved things two ways. One way by graphing, and looking where they crisscross, and one way where we got them both in y equals form, set them equal to each other. Now we need to get the c's on one side, the numbers on the other. I'm going to do this first. Minus a 0.3, minus a 0.3. Both of those don't have c's. So this one was plus, this one's minus. It's canceling on this side. What's 0.4 subtract 0.3?
0.1.
0.1. So on this side I have 0.2c equals plus 0.1. Now I want to move this c to the other side because I'm keeping numbers here, but I'll move the c over. Minus 0.05c, which looks like crazy math, but we have a calculator. Take 0.2 and subtract 0.05, please. Somebody with their calculator. 0.2 minus 0.05. I'm hearing 0.15c equals 0.1. So I've canceled this out. This one's positive, this one's negative. I subtract the negative from the positive. Now, I have a number in front of my c. How do I get rid of that number? It looks ugly, but we have a calculator. Divide by 0.15. Divide by 0.15. Here's the math you need to do right now. In your calculator, 0.1 divided by 0.15.
This is such a long problem.
Yep.
0.67. I got lost.
Point
Second half.
6, 7. Wait a minute. Remember, C is cows. And Jerry thought 0.73. He was closer than Andy.
Hey, yeah.
Okay.
What?
Now, we're not done. Hold your butt. Oh.
I got the 4.3.
Here we go. We need to substitute that into one of the equations to find the amount of time also. So let's see. I'm going to do it into this equation. The time is 0.2 C plus 0.3. 0.2 times 0.67 plus 0.3. Looks ugly, but I have a calculator on. Mode clear. 0.2 times 0.67. And then I'm going to add 0.3. Is... Oh, Andy was good on time, though. He called that one. Time equals 0.434. Oh, my goodness. That's nice. Okay. Okay, so the ordered pair at the crisscross is 0.67, 0.43. Now, sad but true, we're getting close to the end of our time. I don't know if we'll be able to answer these questions because I want time to collect everything and pass out the homework. So wait a minute, don't move. Excuse me. I need calculators and rulers over here. I need that worksheet in my inbox, and I'm going to come around with today's homework packet. Yeah. Send one person up to put in the inbox.
Wait, what are we doing?
Would you like me to stop this?
Yes, please.
In the inbox?
You can turn this in.